Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic and on location. Each time we meet, we bring together a group of IT luminaries to discuss a single concept. In this iteration, we'll be discussing intent-based networking. Before we begin, let's quickly meet who's on the panel today. I'm Stephen Foskett, your host. You can find me on Twitter at @sfoskett, and of course you can find writing at gestaltit.com.
Ivan Pepelnjak, working for the best boss in the world at ipspace.net, and you can follow me at iOS Hints.
Jeff Tantsura. You could find me on LinkedIn mostly or anything at IETF.
And I'm Terry Slattery. I'm at NetCraftsman, and you can find my blogs at NetCraftsman and TechTarget and NoJitter.com.
Excellent. Well, it's glad to have you folks here. Now, I called the three of you together, who are venerated experts on networking, to discuss the most basic of topics.
We fooled them.
I have something that's been concerning to me. It seems that in IT, again and again, we latch onto terms, and it suddenly seems like everyone in the industry is talking about the same thing. You know, we've seen software defined, and I remember back when it was, everything had to be layer 3. Why is everything intent-based now? What are they intending with this? What does that even mean? And Ivan, let's start with you. What is the, industry definition of intent-based networking?
Well, it's very similar to industry definition of cloud.
Mm-hmm.
It's whatever I'm doing.
Yes.
It's whatever will get me funded.
Okay.
Honestly, if we take a look at what people claim is intent-based, or what they're selling us as intent-based, it's more or less the same thing that we've been doing for the last 20, 25 years. It's just that it's becoming more popular because SDN, and we figured out that SDN, can mean anything, so we need the new buzzword, and it looks to be intent-based.
Really? So, in your opinion, when companies say intent-based, I should be thinking what I used to think when I heard SDN?
No, it's a different thing. SDN started as the separation of control and data plane, and we proved that wouldn't possibly work, and some people still believe that, but let's not go there. Intent-based is really an abstraction layer and an orchestration system combined. So instead of saying I want to run OSPF, and then I want to have VXLAN on top of that, and then I want to have VLANs on top of that, and then I want to connect this port to that port, which would be the traditional way of doing things, my intent is to have connectivity between ports A and B, and now let's figure out how that's done by some automatic means. Which, by the way, is the same thing that OpenStack does when you add a VM, and it's the same thing as Amazon does when you provision a VM. So why are we calling this something new? This has been done by the orchestration systems forever.
Mm-hmm. Yeah. So why are we calling this something new? Terry?
It's just something new to this industry.
Okay.
Traditionally, what we've done is, we need to go and put together a network, so we scratch out a design on the back of a napkin during lunch, and we go back into the shop, and we have all the stuff, or we order the stuff, and we rack it up, and we start plugging cables together, and then that napkin or that design has gone away. And the source of truth is the network itself. So intent-based networking is, let's go and write down what our design is, our intent. And it actually says, switch A, port 1, connects to switch B, port 2, and our intent is that is our uplink, for example. And so instead of looking at the network and trying to remember, did we really configure that, or is it really working? We actually have a design document somewhere that says those ports should be up.
So I would say there are many reasons. First of all, proliferation of machine-to-machine interfaces. Finally, we could talk to a router or switch through machine-to-machine interface rather than through SSH and figuring things. Intent has been there since day one. We intend to do something, right? The point being, the modeling intent wasn't there. So with proliferation of data models and availability of machine-to-machine interface, finally, we could take business logic and instantiate it as networking. Proliferation of streaming solution, ability to get feedback loop in near real time, gives us ability to close the loop, to express the business logic, to configure it, and get the feedback. Mm-hmm. So
if I'm understanding this correctly, it really is what it sounds like. The idea is that you would encode your intentions into some, from a business logic perspective, into machine logic, and then the machine would maintain those intentions in physical connectivity, regardless of things changing. Is that right?
Well, that's too much marketing for me. Let's make it technical.
You make me feel bad about myself.
Yeah, so what you really want to deal with is you want to deal with some high-level model of, as Terry said, network design.
Or abstractions.
So my network design says that I have these 5 sites. They are connected with these uplinks, and I have the backup interfaces. However, when you start configuring the boxes, this link between the network design, why we did things the way we did things, and the actual device configurations is lost. So the beauty of this intent-based approach, if you wish, is that if it's done right, then your network design is expressed in some sort of a data model that still retains the original meaning. So the context is not IP addresses, the context is links, sites, connectivity, security rules, whatever it is. And then we translate that, well, the intent-based systems, whatever they are, they translate that into some intermediate data model, which hopefully is vendor neutral, and that gets translated into some vendor-specific data model, because Cisco and Juniper couldn't possibly do the same thing, because then they couldn't charge more. And then that gets translated into Yang data model if you're Jeff, or it gets translated into CLI if you have to deal with some other devices, and it gets pushed down to the devices. Now, the beauty of this approach is that because we still know what we wanted to do, we can execute some show commands on the devices, and then we can use these show commands to verify that devices actually do what we wanted them to do. So that's the closed loop that Jeff was talking about. Because of that, it enables us to continuously verify that what the devices are doing is actually what we thought the devices should be doing.
And so at the lowest level, the examples I gave of the 2 switches connected together, you can verify that that link is indeed operational and doing what it's supposed to be doing, your intent.
Yeah, and
further, with Ivan's example, it's not that I want to figure out after I have configured a device that's not working, it's actually applying intent to my operational state. I should be able to see that it's not going to work, or it's going to work not in the way I intended to. So ability to create future state without configuration is a holy grail of intent network.
Before getting there, I don't know if I will see that running in a production network in my life. We can do that at the point where you can push the future state into a device, and that device would say, yes, I will accept it, or no, I will not accept it because I'm out of resources, or the interface name is wrong, or no, I'm not running OSPF, so you can't put OSPF cost on the interface. But that device wouldn't tell you for quite a while, sorry, Dave, I can't do that. Because whatever. And I don't think we will get to the point where a system will say the network can't do that because you are running this version of Junos and that version of iOS, and I know there is a bug between them, and if you want to implement this, then your network will crash because whatever. I don't think we'll get there in foreseeable future.
I'm not so sure about that. One of the things that I've talked with some people about is the ability to extract topology information from an operational network. You could also get that from the intent-based design and create a virtual instance of the network and any of the number of simulators that are now available. Yeah, there's still some scaling problems with those simulators. But I think the path is clear here that we can simulate the operational network in a virtual environment and do what-if studies, things like that. I think that's something very interesting to come out of this.
What you just described is what Carradine did 20 years ago with the simulators. And there was this other tool that was actually simulating packet flows across the network. What was that called?
I don't remember.
Made by Stanford, by Nick McCone Group. This one?
No. There was a commercial tool
this was NetSys?
Something like that.
Well, if you guys don't remember it, I don't think anyone.
Yeah, there was this one tool that actually didn't do just the topology analysis like what Carradine did. They were passing actual packets around and looking at what would happen under the actual traffic conditions. Those things got as far as they could get without having the actual devices. So what you're really talking about is not simulating the network. It's replicating the actual network in a virtual environment.
Yes, exactly.
So it's like the Star Trek holodeck. The only thing that's keeping us from, well, there are two problems with that approach. Well, three. The first one is the vendors.
At least three.
Yeah, because we can't get the devices in virtual format. The second one are stupid things like interface names, because the virtual interface names don't match the physical interface names. So you have to do some translation between the two and you're never sure whether you got it right. And the third problem is that you run into problems in the data plane that are impossible to simulate because you don't want to simulate the ASICs down to the bit level and the bugs in the ASICs level. You can replicate bugs in software. It's pretty hard to replicate bugs in hardware.
Let me have my optimistic head. So data models give us abstraction of semantics, so interface names, configuration of protocols, configuration as such. Most importantly, it's easy to compare data model to data model. If there's difference in particular leaf value, you know exactly what it means. So rather than trying to analyze post-configuration, hey, this flow doesn't get through, by looking into value, doing proper analytics on it, you could actually figure out before that particular flow is going to change the way it goes through the network, or it's not going to flow at all.
Can I jump in again? I'm sorry. It strikes me as you're discussing this, you guys are talking about how it would be implemented, but the thing that strikes me is the question of, in order to, let's say we have intent-based networking, the real problematic underlying assumption there is that we know what we intend the network to look like, and that intent matches what we want the network to do, and that intent is resistant as things change. Is that even likely? So let's say we have this. Do you really know?
So to begin with, you need a language that's expressive enough to express your intent. You cannot express Shakespeare in 5-word language, right? Number two, you need an API or set of APIs that are capable of understanding this language and translating into something that's networking state. With just two preconditions met, I assume we could try.
But there's a third thing too, and that's that just having a typewriter and a printer or whatever, that doesn't make you Shakespeare, right? You actually have to be Shakespeare as well.
And I think that gets to one of the key points that we were talking about a little bit earlier before we started this podcast, which is we basically have to go and start relearning and reprogramming ourselves as network engineers how we go about the process of designing and implementing networks. We have to start with the intent, and we know we have to keep that intent around. And we don't just, oh, that's the back of the envelope, throw it away, and the network then becomes the source of truth.
And I like this idea. I like this idea that you need to translate your desire. I'm going to try to stay away from the word intent. You have to translate your goals into something that can be encoded specifically and that can be acted upon by the machine. What about as things change? I mean, haven't we spent the last 5 years trying to build things that are dynamic and programmable?
Well, you see,
do your intentions last?
No, that's really easy once you have something like that. You know how easy it is to add a new virtual machine in Amazon or any other cloud system?
Yeah.
Same thing here. The only thing we have to do is we have to stop twiddling with CLI on the actual devices. The only changes we are allowed to do are in the intent data model. Whether that's a text file or a YAML document or an API or an object-oriented database, who cares? But from that data model down, it has to follow the steps we described before. And then you start pushing all the changes to the devices automatically. So the only change you have to make is the change in the data model. And then
how does this happen? How do we get there? Terry, how do we get there?
Well, we have to start with a new method, new processes and new methods. We need the language that Jeff was just talking about.
Well, realistically,
We need buy-in from the vendors and the,
realistically, if you are willing to stay focused on a limited problem, and it can be data center fabric, it can be BGP peering, it can be access control list, it can be a number of other things. There are people who have been doing this thing in production for years. And it's not rocket science. It's just the change in mentality. I know more than one data center where they decided that they will go down this path, and of course they get the CLI jockeys in, and the CLI jockey would go in and change the configuration of the switch, and then someone would change the data model, and his change would just get overwritten. And the team lead said, well, eventually they learn.
So there are more fundamental things, starting to look at network as a network and not collection of boxes. You apply service to a network, you don't apply service to an interface or a box. So ability to understand network as an entity that serves the purpose of creating services rather than configuring ACLs or VLANs or BGP peering, the first step really to start thinking of network as programmable entity.
Well, it doesn't have to be programmed. You can do all we've talked about with the CLI if you wish. It's just the mental discipline.
Exactly.
I mean, there are tools that help you do this better. I mean, there is a reason we started using abacus instead of counting fingers. But even if you were counting fingers, you could do accounting. It was hard, but it was doable. Same thing here. There's nothing that stops you from doing what we discussed and separating transport from services and having a network data model and a services data model and using these rigid transformations to get to device configurations and never touch the configuration again. We can do all that today. There's nothing missing apart from the mindset.
It's just that it doesn't help with the acceleration of the system because we're still using the CLI for doing these configurations. And it's adding additional process on top of it, so there's no reduction in the amount of effort required to do it. Whereas if we have some of these abstractions, then it's an even wash, and it says, here's how you do it, and here's what the benefit is.
Yeah, but the tools are already there. The tools have been there for years. And some people have been using the tools for years. What we really need is not the tools are there. The newer tools are fancier, they have GUI, yada, yada, yada. But that's not the problem. The problem is the mindset.
And I'm going to leave us on that point. And I love that idea. And I love the concept, the core concept of what you're talking about here. The idea that people need to start thinking not in terms of what they can make the box do, but in terms of what they want the box to do, what they want the system to do, as you're saying, not just the box, the system. What do they want this whole thing
and that's key.
to do?
Not the box.
approach.
And that, I think, is something that is a lesson for all aspects of IT. And I'm certain that we're going to start hearing about intent-based storage in 5, 4. So thank you very much.
One more thing.
Oh no, just one more thing. You know what?
2.
Okay, give me one more thing. Lay it on me.
Learn how to say no. Sometimes it's not worth modeling your network to implement the next requirement. Sometimes you have to stay true to your intent.
Okay, stay true to your intent.
So important point, why now? Before, we didn't have really scalable infrastructure to keep all the state, to provide computational resources, to provide ability to compute, and it's multidimensional array of variables to compute. Today, with tools of Kafka with Samza for streaming, they're so powerful. Hadoop, we could utilize all existing big data analysis and ecosystem to support networking.
Any last words?
So I agree 100% with what Ivan said. It's really the gray matter that we have to reprogram.
It's all about people.
It's all about the people.
Soylent Green. Well, thank you for listening to the On-Premise IT Roundtable podcast. If you enjoyed this discussion, remember to subscribe, rate, and review the show in iTunes. That really helps our visibility, and to share the show with more people. This podcast is brought to you by GestaltIT.com, your home for IT coverage from around the enterprise. For show notes on this episode, go to GestaltIT.com/podcast. Thanks, and we'll see you next time.